In this video, we're going to look at a harder example of finding the stationary points of a surface. Okay, so we got our equation here. Step 1 is to find the partial derivatives with respect to x and with respect to y. So let's start with x. So the partial derivative of z with respect to x is equal to, right, so let's go through the terms. So the first term here, x is in there, power of 2, so multiply by 2 to get 6. Then the x power reduces by 1 to 1, and then we've got the y. Next term, negative 3x squared, x is in there again, so multiply by the power to get negative 6, and then the x power is 1. Our next term has y in it only, no x, so it's a constant term. Okay, so that differentiates partially to 0, and then the same can be said with the y cubed as well. That's another constant term, so we're going to get 0. Okay, so that's job done there. Then let's do our partial derivative with respect to y. So the first term's got y in it. It's to the power of 1, so the y is going to vanish, so we're just left with 3x squared. The next term only has x in it, so that's a constant term, so that one's going to vanish completely. Okay, it's going to be 0. Then the next term does have y in it. Okay, so that's going to become negative 6y. And the final term also has y in it. That's going to become plus 3y squared. Okay, so we got our two partial derivatives. Then we can say at any stationary points that both of our partial derivatives must be equal to 0. So at any stationary points, 6xy take 6x must be equal to 0. And simultaneously, 3x squared take 6y plus 3y squared must also be equal to 0. Now, what you're going to do next, and this didn't happen in the last video, okay, is you're going to look at both equations and see is either x or y a common factor of either equation. Now, if we look at the first one here, we have x here and we have x here as well. Okay, so x is a common factor. So whatever you do, do not divide by x. Okay, what you're going to want to do is you're going to want to factorize. Okay, so let's factorize x out because it's a common factor, and I'm going to factorize the 6 out with it. So we're going to get 6x, and in brackets it'll be y subtract 1 is equal to 0. If you just divided by x, you would have lost solutions. The potential solution that x could be equal to 0. That is why you have to factorize. And then we're going to set both of our factors equal to 0. Okay, so we're going to get 6x is equal to 0, or y take 1 is equal to 0. So we get x is equal to 0 or y is equal to 1. So now that I've got those, I'm now going to have to use both of those values separately in the other equation because we haven't actually used that yet. So I'm going to branch off the x equals 0 first, okay, and I'm going to substitute that in to my other equation. So I would have 3 multiplied by 0 squared take 6y plus 3y squared is equal to 0. Now let's simplify. This first term is just going to be 0, so we can ignore that. So it's going to be negative 6y plus 3y squared is equal to 0. Then we have a quadratic to solve, which is a single variable one, and there is a common factor, okay, because I'm going to factorize out 3y. So I would get negative 2, and then plus y is equal to 0. So then for y, we could have 3y is equal to 0. So we would get y equals 0 from that. Or we can have negative 2 plus y is equal to 0. And from that, we would get that y is equal to 2. Okay, so we've actually got two solutions for x equals 0. Okay, when x is equal to 0, y could be equal to 0, or it could be y is equal to 2. So we're now going to have to branch off further on each of these and figure out what is z going to be for this scenario. Okay, so this scenario on the left, okay, I'll just summarize it. It's when x equals 0, because that's the branch we're working off up here, and then also y is equal to 0. Now we have to find what z is going to be. So I'm just going to zoom out so we can see the initial function. Again, we're going to substitute x equals 0 and y equals 0 into there. And actually, this is a fairly easy one to do. Since every term has x or y as a factor, the z coordinate is also going to come out as 0. So I'm not actually going to write out the substitution, but our stationary point is 0, 0, 0. Now let's work with the y equals 2 and x equals 0. So I'm going to summarize here. We got x equals 0 and we got y is equal to 2. Now let's try and find what z is. So we are going to have to write out the substitution for this one. So I get z is equal to, and we got 3 times 0 squared multiplied by 2. Then take away 3 lots of x squared, so 3 lots of 0 squared. Take away 3 lots of y squared, so 2 squared. And then plus y cubed, so 2 cubed. And then you can pop that in the calculator, or actually this one would be easy to do manually because the first two terms are 0. Then we get negative 12 plus 8, so we're going to get negative 4 as our final z coordinate in this case. So then I can write out my stationary point. It would be x equals 0, y equals 2, and z equals negative 4. Okay, so we got two stationary points there. However, if we go back, we've done that all based off the x equals 0. We haven't actually used the x equals 1 yet. Okay, so we're now going to have to make use of that. Now remember, the y equals 1 came from this derivative here. Okay, and so we have to now use the other equation, which is this one here. And we're going to substitute the y equals 1 into that. So I'm going to get 3x squared, take away 6 multiplied by y, which is 1, plus 3y squared, so 3 times 1 squared is equal to 0. Then let's simplify it. So we're going to get 3x squared, and then negative 6 plus 3, so negative 3 is equal to 0. Now we got a quadratic, however we can solve this one by rearranging. If we add 3 to both sides, we get the following. 3x squared is equal to 3. Then divide by 3 to get x squared is equal to 1. And then finally we're going to square root. So we're going to end up with two solutions. We're going to get x equals positive 1 or x is equal to negative 1. Okay, so what we now have to do is figure out z for each of those scenarios. So let's start with the x equals 1. Okay, so let's just summarize where we're at. We got y is equal to 1 on this branch. And then we've also got x is equal to 1. So I now have to substitute both of those values back into the initial surface. So I would get z is equal to, and it's going to be 3 multiplied by 1 squared multiplied by 1. Take away 3 times 1 squared. Take away 3 times 1 squared plus 1 cubed. Okay, and you can go through and calculate that. And I believe we're going to get negative 2 as our value for z this time. So then we can write out our next stationary point. It's x equals 1, y equals 1, z is equal to negative 2. So we got one final scenario to consider, and that is this one here, off the x equals negative 1. So remember where this came from. It's off the branch of y equaling 1, but also x equals negative 1. So we're now going to have to substitute both of these values into z. So z is equal to, and it's 3 multiplied by negative 1 squared times 1, which is y. Take away 3 lots of negative 1 squared. Take 3 lots of 1 squared. And then plus 1 cubed. Okay, and then we just have to calculate that there. So we're going to get, I believe, negative 2 again. So then we can write out our stationary point. So x equals negative 1, y equals positive 1, and then finally z has come out as negative 2.